Hi, I'm here today, Mrs. Taylor from Chapelwood Elementary School. We are in the 5th grade, and today we have the privilege of having Mr. Rick Crosslin here to help us explore the outer planets. Mr. Crosslin?
Hey, thank you. Okay, so that was a nice job. Thank you. So you've been studying the planets, and I know last week's lesson was all about the inner planets of the solar system. And we call it a solar system because at the very center of it is the sun. And the name of our sun is Sol. That's where the word solar system comes from. Also, if you look at what's in our solar system, all the planets and the comets and the asteroids and the moons and the dust, 99.9% of all stuff is the sun. Compared to the sun, everything else is very small. Now, the problem with that is this scale model I have here is wrong, but it's the only model I have. It's wrong in two important ways. One, size. If the sun was this big, shrunk down this big, the planets would be microscopic dots, and I could just say, oh, there's a planet right here, there's a planet right here. You won't be able to, but you understand what I'm saying? So we had to make these planets so you could see them, so this scale is not correct. In fact, if we made the sun 6 feet tall, 6 feet wide, what do you call a circle that's 6 feet across? That's the diameter, right? I heard you guys studying this earlier. So if you have a sun that's in 6 feet diameter, the Earth would be the size of my thumb. Many, many, many Earths could fit inside of the sun. And the Earth is not the biggest planet, and it's certainly not the smallest. So that's why this model is wrong. But it is pretty cool. It can teach us some things. The second reason why this model is wrong, but we need it, is the distances. If the sun was this size, Mercury would be over here. Venus would be way over here. Earth would be so far away that it would be maybe 60 meters down the school. And some of these other planets would be miles away. Now, I can't bring into your classroom a model that's 6 feet tall and 7 miles away where Pluto would be. It just wouldn't fit in my car, you know what I mean?
Mm-hmm, yeah.
So this is a model that's been shrunk down. I want you to know that it's wrong in two ways, size and distance. But it does help us learn about the planets. In fact, one way it helps is that all planets do this around the sun. What is this called?
Rotation.
Revolve, right? They revolve around the sun. So all planets revolve around the sun. And what do you call that path of a planet that goes around? It's called the revolution, and the path is called orbit. The planet's orbit or go around. Now, if you're close to the sun, the journey is pretty quick. 88 days for Mercury. But what if you're one of the outer planets, which we're studying today, past the asteroid belt? If you're an outer planet, it takes sometimes years to go around the sun. You'll learn when you study Neptune and Uranus that it takes hundreds of years to go around the sun. So you really would never have a birthday if you could live on one of these outer planets. Because on Earth, we have a birthday every time the Earth goes around the sun. Happy birthday. Now next week we're going to study how the Earth moves. We'll be studying about rotation, revolution, and season. But this lesson has to do with the outer planets. When the solar system was formed, material came together. There was a lot of stuff coming together. And we had the inner planets, which you know have a rocky core. They're close to the sun. You can land something on some of them. For example, Mars. Right now we have a robot called Curiosity that is moving around on the surface of Mars. It took a year and a half almost to get there, but it's sending back science information right now as we speak from Mars. Now, to get to the outer planets, though, it would take years and years and years. In fact, maybe 10 years to fly a spaceship without a person from here to here. Of course, we know this is not the real distance. So the outer planets we know mostly by spaceships that have been sent past them and by telescopes that have studied them. So we have Jupiter, the giant, Saturn with the beautiful rings, Uranus, Neptune, and our old friend Pluto, which now is not a planet, it's a dwarf planet. I was pretty upset when I found out that they decided, the scientists who study the planets decided that Pluto was no longer a planet. I was like, wow, how can you take away what I grew up with, Pluto being a planet? Then I found the explanation. You see, with telescopes, we've learned that there are over 5,000 objects out here that are the same size as Pluto. And if we're going to call Pluto a planet, then we have 4,999 more objects to name. So scientists came up with a different category. Instead of calling this a planet, it's called a dwarf planet or a planetoid that may or may not one day in the far, far future, other things might add to it, who knows. So these outer planets are so strange to us, and they're so far away that if you were on one of these planets or near it, looking back at the sun would be like a fuzzy white light, not bright like it is for us here on the Earth. So the outer planets are quite different. We call those gas giants. You really couldn't even land on one of these unless it's frozen, because there's no solid surface on most of them. But you'll be able to study these. So let's see if you have any questions. What's your question?
Does Jupiter have gravity?
Does Jupiter have gravity? Well, I'll tell you, every object in space has gravity. Now, a lot of people think, well, for example, on Earth, I'm gonna lift this up and I drop it, go ahead and catch it, and it falls because of the Earth's gravity. But what's confusing to a lot of people is they think when you get in outer space, there is no gravity. If there was no gravity, the planets, the outer planets, instead of orbiting the Earth, orbiting the sun, would just go farther away into the deep space. But it's the sun's gravity that holds it. See, a planet like this one here, Neptune, you're doing Neptune? That's so cool. If you're the sun, Neptune is orbiting the sun. You're trying to pull Neptune towards you. Neptune's trying to get away. What that ends up happening is a nice orbit, usually not a circle, more of an elliptical, around the sun. So the question is there gravity on these planets? Yes. And the bigger they are, the more massive they are. Let me see Jupiter over here. So here's Jupiter. Check this out. Nice. Jupiter is so much larger than the Earth that if you could land on Jupiter, you would not survive. The gravity is so much bigger that the Earth, see this giant storm on Jupiter? That's been going on for over 400 years that we know of. When Copernicus first saw this with a telescope, he saw that same storm. Every 10 hours, it rotates. And it is so big that the Earth could fit in there that if you tried to stand on Jupiter, let's say you're on a vehicle, you would be flattened and crushed by the gravity. Yeah, Jupiter has gravity. Just like if you go to the moon, it's 1/6 the size of the Earth. You have a lot of buoyancy. You could like jump a little bit higher. You wouldn't feel as much the effect of gravity. Great question. So Joel, you're studying Neptune. What's something interesting you've learned, or Saturn, I'm sorry, what have you learned about Saturn, Joel?
I've learned that it's minus 288 degrees Fahrenheit.
You hear what he said? Minus 288 degrees Fahrenheit. And that's on a regular day. You'd be frozen in a microsecond. Excellent. And good drawing. Who's next? And your name is?
Ethan.
Ethan. Wow, I love this picture of Jupiter. Check it out. So you've been doing some research. What's one thing you'd like to share with us about Jupiter, Ethan?
Jupiter has the strongest gravity of any planet.
It has the strongest gravity of any planet. And why do you think that is? It's the what?
It's a gas giant.
It's the gas giant. It's the largest planet, so it has the most gravity. Who's next? Oh, what's your name?
Brandon.
Brandon. And Brandon, you picked Neptune. Neptune, there's some strange things going on in Neptune. What did you find out?
That its name was named for the Sea of God.
It was named after the Greek and Roman god of the sea because it's blue. It looks blue in a telescope. Excellent. Good job. Who else do we have here?
Jason.
And what you have Uranus, one of the strangest planets. What did you find out about Uranus?
I found out about Uranus that it has 15 moons.
It has 15 moons?
It's called Titan.
It's called Titan. Now, one of the moons is called Titan or Titanium. You know, another thing weird about Uranus, it actually rotates almost sideways. Very cool. Because the tilt is really severe. Excellent start to this. So I see you guys have been doing some posters also, and you've done some really good work on your individual planets. Let's add a little art project to this. Are you ready for that? All right, so these are gas giants. So I was trying to find a way that we could duplicate what a gas giant might look like. And so this is a project that's kind of cool, and it's kind of a mess, so let's do it, right? So I got blue, there's some blue, and some green. And yeah, you know, not only do we have gas giants, we're going to have Mr. Crosslin with food coloring. That's all right. All right, check it out. Okay, so here is one of your worksheets. It has to do with the relative sizes of the planets. These are some planets. And you guys are pretty smart here. You probably know what this planet is already. Jupiter. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be your job to calculate the diameter of these and to figure out what they are. And those can go with your reports, and you've already done some work on that. My job is to show you this kind of cool thing we're going to do here. All right, so what I like about this project, it is using shaving cream. Shaving cream is something called hydrophobic. Hydrophobic means it doesn't like water. Shaving cream does not like water. This morning when I did a little shaving, not a lot because I got a beard, I got my face wet to soften my beard, and I put some shaving cream on it to hold that water in. So that's why this does not like water, or water does not like it. So you're going to work in groups. You're going to get some of this, right? It's alive. No, not really. Okay.
It's moving.
I just like to say that any chance I can get. All right, so we're going to get that. Then you're going to use a ruler to kind of make this smooth. And when we smooth it out, we're trying to get some really nice gassy ammonia, methane, gas, planet designs on it, right? Yes, yes?
Yeah.
Okay. All right, so now, let's add some color. If it's Neptune, we got some blues, okay? And some red. If it was Mars, we do a lot of reds from the iron oxides. A red planet, named after the god of war. Now, if it was Uranus, green, but we like green anyway. And you notice that food coloring is kind of sticking on top there. Here's some yellow. When we do this project, the teacher will be in charge of the food coloring and the shaving cream, okay?
Yeah.
All right, let's take a look at this. Okay, so we're going to take a toothpick, and we're just going to, a few little designs on this, you know. I know there'll be some person that'll stir this all up, and that ends up becoming planet yuck, okay? And it's starting to look kind of cool, I think. You know, and so be creative, but less is best. Does that make sense? Less is best. You might leave one. All right, so this food coloring is actually just hanging out on top. This might be the big eye or the storm, okay? Ready? So now here's the fun part. We're going to take this planetary paper and we're going to sit it on top here, and this will cause all of that food coloring to stick to the paper and get absorbed. And it also changes. Each one's going to be different. Now that's kind of cool. Save that. You're going to use that over and over again. I'm going to take my ruler. I'm going to go across this like this. Make some really cool design. Now you see on here, there's a lot of color here, so that's where I'm going to add. And you can practice on paper, but see how if I add some swirly lines like this? That's cool, right?
Yeah.
That's cool. Amazing. Then we'll do like this, and see if those marks come in there. And you can try some different. Now there comes a point when you should stop. I don't know what that point is. And so, that's pretty cool. And there are some gas giants. Who's got a piece of paper I can borrow? Anybody got a piece of paper? Yeah, let me see it. Thank you for volunteering your planet journal. Let's try this. Ready? Dun, 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 dun.
Rest in peace, the Rest in peace, the Earth.
Yeah, not only is it a beautiful Saturn, but it's also something strange going on around Saturn. All right, you guys interested in trying this?
Yes.
Okay.
You wait for her to give you 2 more.
I'm ready. Yes, look how much extra. Oh gosh. You ready? I used this. Sorry. Sorry.
Yeah, now I can do it.
My ruler's too precious. I need to use some. I
hate shaping crevice. Look at that.
I'm trying to put your ruler. Where's my pencil? I'm gonna have to.
Yeah, use your toothpick. Make some creative designs.
Ew. What's that? What do you have? By your eye.
I'm sorry. Look at that, Zion.
Yeah, I get extra colors. I'm so good. Not. Ooh, like ice cream. Yeah, I still get extra colors.
Attention, thank you. I'm going to hand you your paper that you need with the planet patterns on there. And we're going to do what Mr. Crosslin did with the shaving cream in your new creation that you should have ready on your plate. Okay?
You can start when we run already. When can we start? I'm scared I'm gonna mess it up. How do you do that? I'm scared.
You have to peel it back with one hand and hold the plate with the other. Push it on there again. You need to really push it down once you get on there. Now rub it, rub it, rub it, rub it. See how it's coming through? Now lift it up and see what happens. All right, lay it flat on your desk and use a ruler.
Look in the middle.
Yep.
And you can add more to it. Put it on there again, scrape it all the way off.
What is yours look like?
And you can push it on there again. That's pretty cool though. Nice job on that. Nice job.
No.
Oh, I love yours. Turned out really fantastic. Here she goes, the big smear. Oh, amazing gas giant. Scrape it all the way off. And then do it again the other way if you want.
Whoa, that's awesome.
Well, not only are these kids good about science, they're pretty good artists too.
Oh, that looks nice.
It's all about your
Go ahead and fix it up there, Xander.
You go first.
Wow. What do you call that planet? Nice job. Here we have green soup planet and a strange alien world.
Hey.
Very cool. Very nice. Very cool.
wipe off this whipped cream.
Well, if it's whipped cream, you can eat it, but it's shaving cream. Don't. Strange. Now you got to scrape that off. So, as you can see, these kids were pretty good about the outer planets, and since they're gas giants, their artwork matches the science. Neptune, Saturn, Uranus, the gas giants.